What do we mean when we talk about green chemistry? Well, strictly speaking, green chemistry is the design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. More broadly speaking, green chemistry provides a framework that enables chemists to design chemicals, chemical processes, and commercial products in a way that minimizes or avoids the use and creation of toxic side products and waste. My name is Patricia Marr and I'm a senior lecturer in the School of Chemistry and Chemical Engineering at Queen's University Belfast. And I have been involved with green chemistry for the past 23 years. So what makes green chemistry different from cleanup and remediation efforts? Well, the central tenet is don't make a mess in the first place. Green chemistry for me is a philosophy with a set of 12 principles to describe best practice. It's a framework that provides huge opportunities for creativity and creative problem solving and just general brilliance. Green chemists look for creative ways to approach chemistry and minimize environmental impact. For example, one team in Fort Myers, Florida are developing a blue-green algae to produce ethanol and other fuels. This algae uses CO2 from the air or industrial emitters, along with sunlight and salt water to create fuel without using food crops as feedstocks. This is a greener way to produce fuels using renewable feedstocks with no nasty solvents or high temperatures, and it also utilizes CO2. So how do we do it? Well, when designing or redesigning a chemical synthesis or process with a green design, we ask ourselves a number of questions. Things like, can we make sure all of the raw material is incorporated into the final product? Can we use creative or new chemistry approaches to reduce the number of steps required to make a chemical target? Can we design using life cycle thinking? Sustainability is also an important consideration. Can we use chemicals from renewable resources in our synthesis? Can we control the end of life phase of the product by recycling or upcycling? A simple change in a chemical design can have a huge impact when scaled up from pilot plant to a large industrial process. Typically, when we work in a lab, we work in a gram scale, but this translates to tons in industry. Redesigning a chemical synthesis using a renewable resource that produces no waste would be both an environmental and economic advantage, especially when bearing in mind that chemistry provides all the materials for medicine, energy, clothes, and many more items we depend on daily. I believe in the importance of teaching green chemistry as early as possible. This is to empower students so they can approach any future problems they need to solve through a green chemistry lens. Green chemistry also generates fantastic opportunities for creative problem solving. By framing a creative problem such as a chemical synthesis within a green chemistry framework, it provides an exciting intellectual challenge which allows us to create a better environment while providing greener routes to materials, medicines and products. So what's not to love?